Hey guys, what's up? It's Miss DeAngelis here for another fun day of chemistry. Today's actually going to be a great day. We're going to be building an atom through a Phet simulation, which is a computer simulation, and you'll get to do it with a partner, which will be good today because you'll actually have some interaction with your classmates. So let's get into it. So what are we doing today? So today students are going to work with a partner and they're going to build an atom using a Phet simulation. But what are you going to be learning about? What's your focus? Today, you're going to understand that the number of protons determines the type of element. So again, it's the number of protons. So in the number of protons we learn is the same as the atomic number, and that's exactly how the elements are arranged in order on the periodic table, is according to that atomic number. What other fun facts do you have to tell us about Miss DeAngelis? Well, let's see. Isotopes of an element occur when an element either loses or gains an electron. Huh? What's an isotope? We'll get into that in 1 second. But the main idea here is that an element on the periodic table must have a charge of 0. And an element is determined by the number of protons in its nucleus. So again, protons equals the atomic number, and in order for an element to be on the periodic table, the charge has to be 0, which tells us that the number of protons, which are positive, have to equal the number of electrons, which are negative. But hey, tell me something I don't know. All right, so what if I told you that carbon has 6 protons, and I take 1 proton away? It's no longer carbon, because now we've changed the atomic number and it's 5. But if I took that proton and gave it back to carbon and I added another one so that now I have 7, my atomic number is now 7, meaning I'm no longer carbon, I'm now nitrogen. Cations and anions. Wait, huh? An isotope is an element that loses or gains an electron, but it keeps the same number of protons. So you can actually have an isotope of carbon and have 5 electron instead of having 6 electron. It's no longer 0. Now it's more positive because we lost some of the negative. So you become a cation, like this little fuzzy cute cat over here. It's positive, positive. Okay. Now, if you actually gain an electron, you become more negative. So you become grumpy cat. You're not a cation. You're an anion. You're a grumpy cat. So you become more negative. In today's assignment, should you accept it, and you of course will, or I will give you a 0, is to go to this website here. This is where you're going to find your Phet lab. You're going to press the play button and you're going to choose atom. Follow the directions on the lab sheet and you're going to complete the Phet lab chart, and then you're going to take a quiz. And guys, all of this can be done with your lab partner. So you can take your quiz with your lab partner, you can fill out the chart with your partner, but all of your work has to be your own individual work. And finally, my favorite type of ion is a minion. And hey guys, I've had so much trouble with technology. My poor period 8 class, they ended up with a teacher whose screen froze and then it booted me out of Schoology. So if I manage to survive the rest of this week, I would like my straitjacket in hot pink and my helmet to sparkle. So if you see me dressed like that next week, you know how my week ended. And guys, always think like a proton and stay positive. Okay, let's get into our lab. So you're going to have a lab sheet and it's going to look like this. And you can actually type into here, and please type in red. This way I can see the difference, or blue or green, whatever floats your boat. Just do not type in black, because this way it's going to mess me up. So it's just better for me to see your answers in a different color. Now, let's go to your Phet lab here. Okay, so here's your Phet lab. It's going to look like this. So let's say, let me back it up for a second and I'll show you what it looks like when you first get in. So when you first get into the program, it looks like this, and you're going to press the play button. It's going to load up, and then you're going to press atom. So let's build an element. I am thinking that maybe I want to start out with 4 protons. So if I put in 1 proton, I'm hydrogen, and you can see this positive right here. You can see that my ion is positive because I don't have any electrons in here to make it negative, to go against that positive charge. So now I'm going to add 2 proton, and you're going to see that it changed here. It's now helium. I'm going to add another one, and I'm now lithium, and another one is going to make it beryllium. I'm still an ion because I only have positives. Now, if I look at my periodic table at beryllium, I'm going to see that it has an atomic mass of 9. So that means 9 minus 4, I have to have 5 neutrons. So I'm going to go back into my lab, and I'm going to say 1, 2, 3, 4, and 5. Still an ion, but I'm stable now because I have the atomic mass that I need to be at. So I'm at +4, and I have to get this meter down to 0 because see, I have +4 right here and 4 positive. So I'm going to add electron. And remember, what you know about orbital shells is that, or orbital rings, is that on the first ring, we only have 2. And on the second ring, that's when we can have up to 8. So I'm going to add 1 there. And notice right here, positive ion. I'm still a positive ion, but look what happens when I add that other electron. I become a neutral atom. Now let's talk about cations and anions for a second. So if I am going to add an electron, I become more negative. So you can see that here I'm a negative ion. I'm still beryllium because I still have 4 orange proton in here. So again, I am still beryllium. However, I have 1 extra electron. Now I'm going to get rid of an electron, and I'm going to take another one away, and I'm now a positive ion. So I'm a cation, whereas before, when I was negative, when I was negative, I'm now an anion. So you guys are going to work through the directions that you have in your model. You're going to play around with your partner so that you can see, and now my atomic mass is 9, so that you can see how the atomic structures are actually developed or on the periodic table. So here we go. So now if I were to show you, if I'd remove a proton and take one away, I become lithium. Do you notice how adding a proton, my atomic number is 4, so I'm beryllium. If I add 1 more, I become boron because I have 5 protons. So I completely changed my atomic number, which means I changed the number of proton. So I become an entirely different element on the periodic table. So now, guys, let's get into what you have to do. So after you complete your chart over here, your lab over here, we're going to go over and we're going to do the chart. So in the directions, you're going to complete the chart using the periodic table. So here's a periodic table from Flint's Fisher Scientific. It's more comprehensive. I think the numbers that I had on the previous one kind of confused kids. This is strictly the atomic number at the top. And on the bottom, this is the atomic mass. Guys, make sure you are rounding to the nearest unit. So if it is 0.5 or higher, you're going to the next unit. So guys, here's your chart. And the purple numbers that you see here are actually the numbers that this is the information that's missing. This is what has to be filled in on your Google form. So the Google form has numbers 1 through 20, and you're going to be filling in the correct answers. And please remember, if it's an element, to capitalize it. And finally, when you're done, you will be completing the Phet lab quiz. And again, that's in Google form. So guys, please, you are more than welcome to do this with your partner, but the work has to be submitted separately so that you each receive credit. I'm not going to go through matching up names in the grade book. You guys have to submit your own work. So guys, as always, I will see you live right after this presentation ends. And I look forward to working with you guys and seeing all the work you can do when you're creating your atoms. Bye.